Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 18 and in this lesson we will talk about RFID reader interfacing to the Arduino. Okay, so let's have a look at our hardware. Okay, so this is our hardware and here is our RFID module. The number is RC522 and here's we have our Arduino which is connected to the computer. So stay with us to learn more about the programming and the interfacing procedure for interfacing procedure to interface this RFID module with this Arduino. Okay, so let's zoom it out. So further, we also provide online training, help in technical assignments. We also do freelance projects based on data science, Python, machine learning, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So let's start with it. So when we talk about RFID, so it stands for radio frequency identification. Okay, so you may have heard about it a lot because when you go to the supermarkets and if you try to take some component without paying for it, alarm goes off. So RFID module is inside it. Similarly, in metro trains, you have a RFID card through which you can touch and you can actually pass through the gates. Similarly, this RFID card is in logistics as well. Okay, so these are very common module which is generally used for identification of a individual person or individual thing. So RFID, there are two things. One is RFID card and one is the RFID reader. So RFID card reader is used to read the data from the RFID card. So there are two technologies. Generally they are depending on the operating frequencies of this RFID reader, different card category arises. So in general these two categories are available, like EM18, it works on 125 kilohertz frequency range, and another one is this RFID RC522 which operates at 13.5 megahertz frequency. Okay, so we will be learning how to interface this one. These are the interface points for this RFID, and these works on this SPI interface procedure. Okay, so as we have discussed earlier as well, prior to interfacing any new module with this our Arduino code, or prior to writing our Arduino code for any hardware, we need to know more about its pins. So it contains 1, 2, 3, 4, 5, 6, 7, 8 pins, in which this is VCC, this is for reset, ground, it is for interrupt, so generally we don't use it, and then we use this SPI and SCK and MOSI and then MISO, master in, slave out, master out, slave in, SCK and SS. Okay, so these pins are needs to be connected to the Arduino as well, right? So the SPI pins must be directly connected to the SPI pins of this Arduino. Only then we can read the data directly from the Arduino using this one. So let's have a connection diagram, how this connection is made. Okay, so let's go downwards. Okay, so here we have our Arduino. So it has SPI pins are available from 13 to 12. So we have this pin number, okay, and 9, 10, 11, 9, 10, 11, 12, 9, 10. Okay, 9, 10, 11, 12, and 13. So this particular pin is connected to the RST of this RFID. So these are the RFID RC522 pins, right? So pin number 9 is connected to the RST, pin number 10 is connected to SDA, then pin number 11 is connected to MOSI, master out slave in, pin number 12 is connected to MISO, master in slave out, and then pin number 13 is connected to the SCK pins of this card. Okay, so a simple connection. And then VCC pin is connected to 3.2 volt of 2.3 volt of Arduino, and similarly ground is connected to ground of this Arduino is connected to ground of the this RFID card, right? So this is a hardware connection, and if we look at our hardware, yeah, here if you look at the hardware, so all these pins are connected from here, from this RFID card to the Arduino, and then VCC and grounds are connected from these two pins, right? 3.3 volt is connected there. So this is how we have connected this Arduino. Now talking about the programming part of it, so there is a library, zip library, which you can find over the internet. It is simply RFID. Okay, so this particular library files have been used for this purpose, and then now we will go to the programming part, how to write a program for it. Okay, so let's open this Arduino and let's create a new okay, so let's open this Arduino and create a new file. Okay, first of all, what we'll do, we'll save this file, let's say at desktop, lesson 18 RFID, and then save. Okay, so if you are new to it, we can add the library by going to the tools, and here maybe there's an option manage libraries, and if you click on manage libraries, this will option appear. Okay, we don't want to go through this. Here must be something, yeah, include library. Okay, so include library from add zip library, and go to desktop and select your RFID zip library and then open. Okay, so in that case, yeah, it is saying a library name RFID already exists because we have already added to our project. So here first of all we need to create hash include RFID.h. Okay, we have added the library. Then first of all we need to create a RFID object, and this RFID object needs two pins like SDA pin and the RST pin information. So what we'll do, we will create constant variables for this. SDA underscore pin is equals to 10, so our SDA pin was connected to pin number 10, and then RST underscore pin equals to 9, so RST pin was connected to pin number 9. Now we will create our RFID object, RFID, then RFID SDA underscore pin, comma RST underscore pin. Okay, so these two things are done. Now let's delete this one First of all, we need to initialize our SPI. So SPI dot init, okay, SPI dot begin, and then we need to initialize this RFID. So RFID dot init, and then we will be sending this card number, which we will read from this RFID card, to the serial port. So we will enable this serial communication as well. So serial dot begin 9600. Okay, so now it's about writing a code. So there is a function if RFID is card. So if there is a card is placed near to it, first of all it will check whether card is present or not. So there is a command RFID dot is card. So it returns a logical value. That means if RFID card is present, it will return 1, otherwise it will return 0. Okay, so yeah, we can go like this. Yep, here. So now we will read this RFID card information. So there is a command RFID dot read card serial. Read card serial. Okay, there is a read card serial. Okay, and then this particular thing read the card serial number and store all the result in a variable. Okay, so there is a variable within this library by the name of our serial num, ser num. Okay, so it is and here is the file. So actually this RFID cards, this HRs, this RC522, these cards contains a 40-bit of information, right? So if we divide by 40, so there are 5-byte information related to the card. So in order to store all these 5 bytes, there is constant character array is defined within this library, which at every location it stores a corresponding digit number or the byte number of the card. So we need to read this particular array in order to read the card detail. So as soon as this particular command is executed, it reads all this 40 bytes information and then stores the data in this serial .num array variable. Okay, so we can read directly. Okay, so now let's send all this digit which is restored in serial num variable to the serial port one by one. So we will write serial dot print RFID dot serial num underscore 0. So the first location, and then in order to show some difference between these values, we'll send a comma in between, and then serial dot print RFID dot serial num first location data, and then serial dot print, and then serial dot print RFID dot num second, and then serial dot print, and then again serial dot print RFID dot serial num third. Okay, and then serial dot print again, and the last data. So RFID dot serial num 4. So this is the last byte information, and after that we will create it will keep on reading the data as long as the RFID card is within the range of this reader. So in order to repeat the data sequence again, we will create a separate line. Okay, serial dot print ln, we can write a space character there, right? Okay, after that, before going to so now at the end we will provide a delay so that it takes some time while keep reading on continuously again. Okay, so let's provide a delay of 2 seconds. So we can do that by providing delay of 2. Okay, so now it's done. So let's download the program. Okay, let's first check our port is connected. Yep, let's upload the code. Okay, it has been uploaded. So let's see our hardware. So here's the hardware, and let's open this serial monitor. Okay, here's our hardware. So okay, it is reading. This is the card number 230231, and on each 2 second interval it is keep on reading it. So let's change by this card. Okay, so instead of this, let's change another one. So right now it is not reading, there is no card. As soon as we apply it, okay, it is reading the card. There is another information. So let's try to change the card again. Okay. After providing this 2 second of delay, the operation has been slowed down. Okay, so you can speed it up by providing a less amount of delay. So I hope you understood how to interface this RFID card with this Arduino, and through this you can create very interesting projects like RFID based door opening and closing system, attendance system, and many more. So I hope this tutorial video will help you a lot and you have enjoyed this video as well. And if you have any suggestion or any doubt, and you can let us know by commenting below this video. Okay, so finally we also provide online training, help in technical assignments. We also do freelance projects based on data science, Python, machine learning, embedded system, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. info@jcbrolabs.org. So that's it for this video. Thank you.